So jumping right in to DOM utils. So this is following on from 2 weeks ago, the core utils package. And whereas the core utils package was utilities that didn't have anything to do with the UI or any dependencies on the DOM, so they could be used from Node or any other JavaScript runtime that you want that's not in the browser. DOM utils does have a dependency on the DOM, and so that's why you got core utils, which is non-DOM centric, and then DOM utils, which is DOM centric. So that's why there's not one single utility package, but two separate utility packages, because one has a dependency on the DOM. So jumping right into that. We got a few sub-modules within this package, and one of the patterns we use in Phosphor is that every top-level package will have an index.ts file, which if all of the content doesn't fit in that index.ts file, it simply exports all of the public interfaces and functions and whatnot, all of the public stuff from the sub-modules in those packages. So you're never going to, let's say, import from Phosphor/DOM utils/ platform, for example. You'll always just import from Phosphor/DOM utils. So just an aside, everything in Phosphor follows the same structure for the packages. But starting right in, we've got just similar to how you saw in algorithms, where we had like an array ext namespace or a string ext namespace, which is basically extensions to arrays or functions that should be in a JavaScript standard library for arrays or for strings or that kind of stuff. We've got the same kind of pattern here, where we have element ext. So these are functions that and utilities that are related to dealing with DOM elements. And so one of them is a function to basically get what I call the box sizing of a node, which is all the information that's associated with the padding and the borders for a particular element. So these are obviously things that are defined in CSS. And so this utility function allows me to get the computed style for a particular element, compute what all of the borders and paddings are, convert those from strings into numbers, sum the horizontals and verticals. This is all information that's really important when you're doing your own layout in JavaScript. And rather than reading them on demand from the style, which may cause layout reflows if you mix reads and writes things from the DOM, we get all of that information in one read and hand that back as an object to the user. So this is what box sizing does for us, the box sizing function. And then similar and related, but not necessarily the same thing, are the size limits or the extents of an object. So these are its minimum, maximum widths and heights. And there's also a function that gets that information for you. Again, gets it from the computed CSS style of the element, converts it into floats or converts it into numbers, and then returns you back an object with that information. Again, very important for layouts. So this is used all over Phosphor widgets whenever we're doing our own manual positioning of elements for layouts, because this is information you have to have in order to do a proper layout. There's also a utility function to hit test to see whether an element lies or intersects a particular client position. Again, there's nothing there. This is something that should be, in my opinion, in a JavaScript standard library, but it doesn't exist. So we have that function. It's fairly simple. You get the bounding client rect for an element, and then test whether that point is within that rectangle. But it's something that you need so often when you're dealing with UIs and user interactions and drag and drop and that sort of stuff, that it makes sense to make it a utility function. So here it is. And then the final utility function for dealing with elements is this thing called scroll into view if needed. So this is really helpful if you're doing a manual scrolling of various things. For example, we do this, this function I believe is used in the notebook quite heavily. So when you bring focus into a particular cell in a notebook, if that cell is not entirely visible within the client viewport, this function can be called on that element, and you basically pass it the area, which is basically the canvas that contains the scrolling elements, so the area element that you care about, and then the element within that area that you want to make sure is on the screen. And if it's not fully within the current client viewport, it will scroll it to position either closest to the top or closest to the bottom, depending on where it's overlapping. So this is a pretty useful function whenever you're giving focus to something that might be on or off screen, or partially on or partially off screen, and making sure that it's scrolled into view. So there's a utility function for that. All right, moving on to the next one. This is pretty simple. This is very simple platform detection. There are certain cases where we need to know if we're running in an IE browser or the Edge browser, or whether we're on Windows or on Mac, for dealing with things like platform-specific key bindings, for example, or particular quirks in IE and Edge versus Chrome or Firefox. Most of Phosphor is written to be platform and browser agnostic. There are a few things, though, that needed to make these distinctions. So rather than repeating these regex things all over the place, we just made it a module in DOM utils, and you can use it if it makes sense for you. If not, you don't have to. This is admittedly not the most robust edge detection or platform detection in the world, but it works for our case. So, so there it is. There are definitely more, what I want to say, comprehensive platform detection modules available out in the wild if you need to use them. But again, you know, Phosphor tries not to have any external dependencies. Certainly, I'm not going to bring in an external dependency for platform detection. So that's why that submodule exists. Now, Selector. Now, this is actually a really useful module. It allows you to determine, basically calculate the specificity of a CSS selector according to the CSS standards. So if you're doing anything, this is, in particular, we use this in the keyboard module or the commands module for dispatching keyboard shortcuts or finding which keyboard shortcut matches a particular command. And to do that, the commands and keyboard bindings and all that kind of stuff are scoped on CSS selectors. This is very similar to the way the GitHub's add-in editor does things. And so in order to do that, in order to break ties and know which command should be executed or which key binding should take precedence, you need to be able to calculate the specificity of a CSS selector. And the rules for calculating that specificity are well defined in the DOM standard. And so this module basically implements that behavior that's defined in the standard. So you can calculate the specificity of a selector and gives you back a number. It only computes it once for a given string and then caches it. It also allows you to detect whether a CSS selector is a valid selector. That's something that's useful if you're trying to do basically robust error detection, since the user is specifying selectors as strings. You know, they may have a typo in something. They may give you a selector that's not valid, and you'd rather know that before trying to either calculate the specificity or test whether it matches whether an element matches a particular selector. Rather than getting an exception, you can test whether it's valid first. And then we have another function, which is, you know, you call this a selector.matches, and you give it the element and the selector you care about, and that will return true or false depending on whether that element matches a particular CSS selector. This is actually something that exists in the DOM, but not in all browsers, because not all browsers implement the spec correctly. And so what this function does is basically privately it determines a function that it should call given the particular browser that it's running in, or particular runtime that it's running in. It basically does that platform selection for you. So rather than having to figure out what function you need to call yourself, depending on what browser environment you're running in, Phosphor's already done that for you. So you can just call selector.matches. So we actually go down and look at how that is computed. We have this prototype match function right here as a self-executing function. And it basically picks whatever method exists for the runtime that you're running in. And if none of those work, it basically falls back to a slow path where it queries the document for all elements which match the selector, and then tests whether that element is in that match. So this is a very slow way to do it, but it's guaranteed to work. And so if you don't have one of these, if you're not running in a new browser, this will always work. So that's the public interface for this, and then the private interface is basically just implementation details. I don't think I need to go through all of it. If you're curious about how specificity is calculated, you can basically look at this private implementation. There's a bunch of different regexes that go through and parse out the various parts of the CSS selector and then assign values to them according to the specification. So again, I don't think I need to go through it. You can read the spec if you want. If you don't care, you don't have to care. So I think that's it for DOM. It's a pretty small module. Most of the browsers nowadays are pretty advanced. The evergreen browsers, like Edge and Firefox and Chrome and Brave. If you're running on the bleeding edge of those, or whatever the most stable version is, which is what we say that we support, Most of those browsers are pretty advanced now, so you don't need that many DOM utilities anymore. You certainly don't need jQuery anymore. The exception would be IE, but JupyterLab doesn't support IE. I don't know if we need to support it much in Phosphor anymore either, since JupyterLab doesn't support it. So that's why this package is small and hasn't been touched in 2 years, because we didn't need many DOM utilities. So this is another module that shouldn't have to exist, but because JavaScript doesn't have a good standard library, and because the browsers can't agree on what the keyboard specification for the DOM should be, this module exists. So this handling key events robustly in the DOM is probably the most difficult thing to do in the browser, full stop. The APIs are so bad that it's really quite incredible. So there's basically 3 different ways of trying to determine what key a user has pressed. Of those 3, 2 of them are officially deprecated in the DOM spec. The one that is supposed to be officially supported by the spec is not implemented by all browsers, and the browsers that do implement it incorrectly. And Firefox is the closest to getting it right, but it's still incorrect in spots, and it's not even consistent with itself. So it's a really bad API. Like, I'm not kidding that I lost a lot of hair dealing with this. So what we're using currently is one of the deprecated ways of reading key events, which is the key code property of a key event. And the reason we're using that is because it's supported by all browsers, and most of the browsers support it in the same way. So even though it's deprecated, it still exists, and most browsers behave the same. So we can at least use it. The problem with it is, and there are many, the key code that's actually provided to you by the browser is actually the USB integer code of the key that was pressed. So you don't know the character that was pressed, because USB key codes are independent of keyboard layout. But what you do know is that, let's say that, the user pressed key code 105, and I'm just going to assume that that's a W on an English keyboard. I don't know if that's correct or not, but let's just assume that it is. So if a user is running an English keyboard and they press the key W, I get key code 105. And then let's just say that a user is on a German keyboard and that key is R on their keyboard. I don't know if it is or not, but let's just say it is. I'll still get key code 105 because it was the same physical button on the keyboard that was pressed. It might have a different silk screened letter on it because they're using a different keyboard layout, but nevertheless, it's the same USB key code. So that means that we need a way to translate from those USB key codes to the actual character that the user pressed. That is what this keyboard layout interface does. So rather than just statically assuming we're going to be using this key code, basically this key code events, or the key code attribute of key event for all time in perpetuity, and using that to translate from key codes to letters, I created an interface, which is called the keyboard layout interface, which has a couple of convenience methods on it, which one of them is, it's got a name, which is for, again, user debugging purposes, so you can associate a human readable name to the keyboard layout. The other is a method that will return to you all of the valid keys that can be handled by this keyboard layout. Again, this could be useful if you're writing a UI and you want to present a list of characters that the user can type to create a keyboard shortcut. That's what this method is intended for. There's also a method to test whether a user provided string key is a valid key for that layout, and then the meat and potatoes of it is a key for key down event. So what this is that whenever I get a key down event, I get whatever the current keyboard layout is, and I hand that event to this method, and it's supposed to return back to me a string, which is the character that the user pressed. So this is that level of indirection that eliminates me, A, forever relying on the key code property of a key event, and allowing us to move forward in the future when the browsers actually support the DOM standard properly. We can move off of the key code way of doing things by providing a new keyboard layout implementation. But it also allows us to have multiple keyboard layouts for different languages. So if a user is using an English keyboard, we could have a US English keyboard layout. We can have a German keyboard layout, a French keyboard layout, etc. We just have to manually write what those are, and that'll make more sense as I get to the bottom of this module. But that's basically what this is the meat and potatoes. So you translate a key down event into a character string. And then from there, whatever module is consuming this keyboard module, like the commands module, which actually does the shortcut processing, it can go along and basically work in character strings rather than keyboard. Then similar to the messaging module and the signaling module, how you can get and set the singleton exception handler, you can get and set the singleton keyboard layout for your application or for your runtime. And so the reason that this is a singleton is because it's very, very unlikely, except in the most rarest of circumstances, that a user is going to have two keyboards plugged into their computer and want to have different keyboard layouts associated with each of them. So on startup, this module is assuming that the keyboard layout is US English, because I wrote this module and I use a US English keyboard layout. If, for example, Jupyter Lab starts up and they want to start supporting different keyboard layouts, on startup, Jupyter Lab would figure out which keyboard layout is appropriate for the user, call set keyboard layout in this module, and then everything else in Phosphor that needs to work with whatever the keyboard layout, whatever the current keyboard layout is going to be calling this get keyboard layout function, and it will then be using the one you've specified for the user. So that's what these two static functions are for. And then down at the bottom, we have a concrete implementation of one of these keyboard layout interfaces, which uses that key code property of the key down event. Again, the key code property is deprecated. There's a couple issues on Phosphor filed about this. Jason Grout filed them, but again, it's the best we've got, and it's the one that currently works. When browsers start actually supporting the DOM standard correctly, we can still have this, but we can create a new default keyboard layout, which actually uses the newer proper standard of the key event. But until that happens, this is what we get. And so basically what this, the way that this keyboard layout works, that when you construct it, you pass it, the user readable name that you want for this particular layout, and then you pass it one of these code maps, which is a type definition here, which maps the numeric key code value to the character string associated with that. So you could think of a way that, we provide a utility to users to generate these code maps. You just write a little UI and you tell the user to, basically you show them all the characters you want to support or whatever, and have them hit that key on their keyboard, and you record the key code number that was generated. And then you build a map that maps those numbers to those character strings, and there's your code map. Basically what this key code layout does is it implements that interface. And so it takes that, code map that you give it, it inverts it, so it has one map that goes from numbers to characters, and it has a number map, another map. Sorry, no, it doesn't have a number. It just goes from key codes to characters, and then it extracts the actual characters from that code map, so it can implement that keys method. And then the key for the key this implementation of this method, it just simply looks up in that map for that current key code and returns the character associated with that that's defined in the map, or it returns the empty string if it's not found. So very simple. It's a very high performance implementation of that keyboard layout. And if you look at what one of these maps looks like, here's the US English version of that key code layout implementation. And you can see I've actually gone through and pressed all of the keys on my keyboard and recorded what numbers are used. And then you see a little bit of comments here that say 59 and 61. These are used for Firefox. No other browser has conflicts with 59 and 61. And then there are a couple other ones that are for Firefox and non-Firefox. So basically, we can create a single table that works, or a single map that works for all browsers. You don't have to do any platform detection. It just happens to be the browsers worked out that way. So this is the US English keyboard layout. If somebody wants to create one for German keyboard or a French keyboard or whatever and submit this as a PR, if you have one of those keyboards, please do it. I'll accept that PR immediately, and that will give us some default keyboard layouts for other than US English keyboards. Okay, so moving on to the commands module. So this is a commands package. This is a single module package with one class in it. It's called the command registry. And this is an implementation of the command pattern. Now, there's a variety of ways to implement this, but you could also look at Wikipedia, the definition of the command pattern. But basically, it's the command pattern is more or less an abstract function that has some concrete fully encapsulated action where you either call the function or you execute the command, and it takes some action, and you generally don't care what the result of it is or how it did it. So the simplest implementation, obviously, of a command would be a function that takes no arguments. Other platforms implement these things differently. C# has the concept of an iCommand object, which is an object with an execute method. Qt has a thing called an action, like the Q action. So that's another implementation of this command pattern. Ours, we implement it as a registry where you can register essentially functions that are associated with a command name. And when the user executes a command name, you can take the action, you can provide the labels for that command, the icons, all sorts of other visual metadata or metadata associated with that command. And the big reason we went with a registry instead of independent objects, and we went with string command names, again, over independent type-safe objects, and this is very important, it's so that you can set up key binding maps and potentially in the future context menus and menus as JSON files on disk. So rather, if I made the decision to create concrete command objects like you have in C# or in Qt, you wouldn't be able to do that. You wouldn't be able to write a JSON file that says, hey, when the user presses this shortcut, execute this command, because that command name needs to be a string. And so that's why the command registry is based on string command names and not objects. So if anybody's ever used Sublime Text and customized Sublime Text, or used Atom and customized that, they do the same kind of thing. When you register key bindings, there's a command name that's executed in response to that. Or when you use JSON to define menu hierarchies, you use command names that are the things to do when the menu item is clicked. We use the same thing in Phosphor. So this command registry has two functions. One is a registry of commands. So if you're a command author, you're going to grab the global command registry. It's probably going to be part of an application object. And you register your commands with it. And that's going to be basically registering a string name, which is the command name for your command, and an object that has a bunch of callback functions to actually execute the command and provide all the various metadata for that command. The other main responsibility of the command registry is to dispatch registered key bindings to the commands that should be invoked when that key binding is triggered, and also listening for those key bindings to be triggered. And so if you're a user of an application and you want to register some key bindings, you're again going to grab the command registry and you're going to register your key bindings with the registry. So there's two separate parts and there's two separate users involved. One is the author of a command that registers their command with the registry, and the other is the author of a key binding that registers those with the registries. And that might be two different people, particularly in an application like JupyterLab, where you're going to want the user to be able to provide their own custom keyboard bindings. They're not the person that wrote the commands, but they're the person that's binding what keys, their key bindings to the commands to be executed. So in a broad overview, that's what the command registry does. Now, just going through it, one particular property at a time. The command registry doesn't take any constructor args. It's pretty self-contained, so you just instantiate it and make it available. You can have more than one. They're not going to trounce each other, but typically you're going to have one per application. There's a signal that you can listen to for when metadata has been changed, like when commands are not necessarily or added or removed or particularly changed. There's another signal that is emitted when a command is executed. And if you read the note, it says care should be taken when consuming the signal. It's intended to be deep for debugging and logging purposes. It shouldn't be abused for general purpose spying on command execution. So this is really useful if you're trying to debug a problem with an application and wondering whether a command is executing in response to a key binding or not. You can listen for this. You can listen to this signal and start, printing debug logs to your console and that sort of thing. So that's what this signal is for. Again, you shouldn't abuse it or use it for nefarious purposes. There's also a signal that's emitted when a key binding is changed. And I believe that's all the notification signals on the class. There's a read-only getter that provides you what registered key bindings are registered with the registry. If you're going to be writing a UI, say in JupyterLab, that tells you what the current key map is or what current key bindings are registered, so the user can kind of figure out what's available to them. You can go ahead and grab this object here, or this read-only array of key binding objects, and convert that into an appropriate UI display. There's also a method that'll tell you what commands are registered. So this gives you all the command names as an array, an easy way to test whether a command is registered or not. A method for adding a command, obviously, to the registry. So this is probably the one that you're going to use the most often. And so it takes 2 arguments. The first is the command name. This is a global namespace, and you can't have 2 commands with the same name. So the first thing that's done is we check to see if that command or a command with that name has already been registered. And if it has, we throw an error. What this means is that you should probably namespace your commands. In JupyterLab, I believe we use like a namespace : command name, where the namespace is going to be like the name of the module or something like that. And this is playing nice to make sure that your commands aren't going to collide with anybody else's commands. You own the namespace for your package, so you might as well use that as a leader for your command name, and then a colon in the actual name of the command. The second argument is the options. So I'm going to scroll down to this definition so we can see what that is. So that's going to be down here. So we have, this is the iCommand options. So you can pass in this object when you register your command. There's one required function, which is the execute method. And this is the thing that actually does the action for your command. And it can either be a function, which is a type definition for a command function, which is a function which takes a read-only JSON object, which is the arguments, and returns some value t. And so the execute function returns a value which might be null, or it might be the result of the command. And it can either return the value directly or return a promise to that value. So commands can return values if you need them to do that, and they can be asynchronous in their action. I believe most of the commands that we have in JupyterLab return void, so they return nothing. But I'm not sure, Jason, do you know off the top of your head if there's any that actually return values?
I think there are some return values. I think I saw the open command or something the other day. I was looking at it. I think there are some that return values. And
we have a lot. We have a lot that return promises that indicate restoration is done, so that their return value is actually checked.
Okay. Yeah, and I think Ian left a comment that said the doc manager returns a promise to the file or whatever that's open. Yeah, so there is a use case for obviously returning values from a command. The rest of the options for the command are all optional, and it's all metadata associated with the command that can be used to help build up a UI surrounding these commands, or visual representations for a command. So, the notes are pretty good here, documentation for these, and the typical pattern you're going to see is you can either provide the value directly if it's a static value, or it can be a function which computes the value based on the arguments. So this is really, really handy. Let's say you have one command. Let me explain the use case that I had in mind when allowing you to provide functions which return the UI data based on the arguments that are passed to it. So let's say you're making a command that's going to go in a menu, in like a drop-down menu. And let's say this is going to be the file open recent submenu of your menu bar in your main application. Well, you might want to have the 5 most recent files that you've used in JupyterLab be available on that open recent menu, rather than every time you open a new file having to delete the 6th oldest command and then add a new command, which is the file you're going to open, and have that label actually be the file name. You can create one command which takes an argument, which is, open history file or open recent history or whatever. And in your menu, you can register 5 menu items that use the same command but take different arguments. And that argument might be, those arguments might be n equals 0, n equals 1 through n equals 5, or n equals 4, however many number you want. And that command, when the Phosphor comes around and asks for the label for that particular item, it's going to be passed that arguments object, which is going to have n equals 4 on it. And that that command function can then go look up the label for what n equals 4 in that recent history. And so you only have to have one command. You never have to change the command registry. You never have to delete or add new menu items or anything like that. You can dynamically compute what the labels and what the mnemonics and what the icons should be for those particular menu items, or your command palette items or whatever, based on the arguments that you've been given. So that's why all of this metadata can either be the value directly, or it can be a function which returns that that value. Does that make sense? I hope I explained that well.
Yeah, and we use that quite a bit in JupyterLab. There is one option that is enabled that's more than just UX here.
Yes, there's mostly UX. Okay, so you have an option for the label. This is used by the UI, like I mentioned before, in command palette items or menu items to actually show the text to the user, what it should be. The mnemonic is the index of the character in the label, which can be used to provide single key keyboard access for triggering a menu item. So whenever you open a menu, for example, in Windows, and you see a character that is underlined in the label, that is a mnemonic. And so when that menu is open, you can press that character on your keyboard, and that menu item will be highlighted. So you don't have to, scroll there with the mouse or use the up and down arrows or whatever to highlight that menu item. You can just hit the mnemonic, hit enter or hit space or whatever, and that menu item will be triggered. So you can provide the mnemonic index if you like. This is deprecated. We made it a little bit more. The icon is deprecated. We use icon class now instead. So this is a class name, a CSS class name that will be added to the node for the icon for the visual representation of the command. So in a menu item, you might have an icon next to that menu item, or in a command palette, you might have an icon for the command palette item. In order to set those icons, we don't want to do that necessarily in JavaScript because a lot of that stuff is better done in CSS. So what we do is tag that particular node that we render for the icon with the class that you provide for the icon class. You might also want to provide a label for the icon. You might want to provide a caption. So the caption and the usage may be used, it may be not. So the caption, you can imagine, depending on the UI and depending on what you want to do, this might end up being hover text for a menu item or for a command palette item. I believe actually in the command palette we use this as lowercase subtext for a command palette item, but on a menu item it might be a hover text, for example. Usage, if you're going to, let's say, present a large documentation page to the user of all the commands that are registered, you might have some really verbose documentation about how to use this command, what it does, what its effects are, that kind of stuff. This is really human readable, long form text that you might provide for a command. Class name, this is a CSS class name that's added to the primary node for the visual representation of the command. Data set is the same kind of thing. This is the data set that will be added to the DOM node for the visual representation of the command. Is enabled, is toggled, is visible. So these are things that may or may not be related to the UI. So you might have a menu item that is visible, but it's not enabled because it's not appropriate to be clicked on at the time. So this would be visually presented as a grayed out menu item or a grayed out command palette item. Like you can see it, but you can't click on it. It does nothing if is enabled is false. Is toggled. So if you've got a menu items that can be checked or unchecked, you would represent that by returning true or false from is toggled. And is visible is just what it sounds like. If you want something to be visible or not visible in a command palette or in a menu item or something like that, you can use the is visible flag. Now again, this is all metadata. The command registry does nothing with any of this. It's all on the users of the command registry to interpret this data as they see fit, all of this metadata. The only thing that the command registry itself will use is the execute function.
I think,
and that's when you actually try to execute a command.
Chris, I think the keyboard shortcut processing uses is enabled as well.
Yes, that's true. You're correct.
So that's, I think, the one thing that's not totally UX driven that is enabled is about.
You're correct. Thank you. Yep. Okay, so going through, so that's the, where are we at? That's the add command method. So those are the options that you can provide with a command. The thing that you get back is a disposable, since the command registry typically is used as a global, and you should the person who adds their command should be the only one responsible for removing their commands when they no longer want it in the registry. There is no remove command method, because then anybody else that has access to the registry could come along and remove your command out from under you. So instead of that, instead of a remove command method, we return a disposable. This is, one of the uses of that disposable interface that we talked about a couple weeks ago. It's useful all over the place. This is one of those things. So you get back a disposable object, and when you call dispose on it, your command will be removed from the registry. So you're the one that registered the command. If you keep this disposable object private, you're the only one that can unregister the command. So that's why you get back a disposable. There's also a method called notify command changed. This exists because there might be times during the execution of the application that the metadata associated with your command has changed dynamically. Let's say, for some reason, some state in the application changes and your command is no longer enabled. When that happens, you call notify command change. That'll end up calling the command, that'll end up emitting the command change signal. And any part of the application that's listening for those command changes will know what has changed, how it's changed, and what to do about it. And in the case of the UI, it might be re-rendering stuff in a command palette so that the things that were enabled are now no longer enabled. So it's very important that if you have metadata or the results of computed metadata, when those have changed at runtime, that you call this notify command change method so that everybody else can react to that.
With the ID parameter to this, we've had discussions in the past in Jupyter Lab about whether you should just call notify command changed for like sort of all commands something possibly could have changed, or if you can scope to a single command. You have some guidance here in the ID parameter here. Is the reason for this guidance that if you have two possible commands that could have changed, omit the ID parameter? Is the reason for that so that the signal is only emitted once?
Basically, yeah. Initially, we had it so that the ID parameter was required, and that ended up being tedious because we were emitting a signal like 13 times when something has changed. If I were to go back and do this all over again, you would never pass in the ID, and anybody that cared about commands, there would just be notify commands changed method, and then everybody would just re-render. Since everybody's using virtual DOM anyway, the ID parameter is not really important. And
so you're assuming here that it's cheap to re-render your UI based on the signal.
Exactly. And I couldn't go back and just remove the ID parameter entirely because we had already reached 1.0, and that would have been a breaking change, and so I made it optional. So in general, you should just call notify command change and pass nothing as the argument whenever any commands have changed. And you only have to do it once if you don't pass in. If you don't pass in the ID, you only have to call it once. So
thanks.
The next few methods are methods on the command registry to get that metadata for a particular command. And the pattern is always the same. You pass in the ID of the command, and you pass in any of the arguments that are relevant for that particular command. Lots of commands take no arguments. Depending on how you've written your command, it may take arguments. And again, the arguments is a read-only JSON object. And again, the reason for that is because we can store it in a JSON file. So you might have a command that you want to bind a key binding to in a JSON file, and that command might take arguments. That means you need to be able to write those arguments as JSON as well. That's why arguments have to be read-only JSON objects. So, so there's functions to get the label, the mnemonic, the icon, all of that stuff that was options on the command options that you pass in when you add or you register your command. There are methods to get that metadata for each one of those options. Okay, and then we've got down at the bottom, near the middle of the class, but at the bottom of the command-ish functionality is the execute method. So this is how you execute a command. You pass it the ID, the arguments for the execution of the command, and you get back a promise, which resolves to anything. So it's going to be the result of the command. It might resolve to undefined if the command returns void or whatever. If the command, and it's never going to throw, it might reject the promise if the command doesn't exist, or if the command execution itself throws an error, or that kind of stuff. But you basically always get back a promise. Okay, and then you have a way to add a key binding to the registry. So there's some options. You basically pass in an options object, and we'll go over what that is. It's useful to read the notes here. I'm not going to read them out loud. So anybody that's ever used the Atom text editor, this behavior is exactly the same. as what Adam did. So now it's probably a good idea for me to talk about why I chose to use CSS selectors for key bindings as I scroll down to this key binding option object. So key binding options. So this is the options object you have to provide to register a key binding with the registry. Notably, this object implements the JSON object interface, so it's nothing but arrays and strings or other JSON objects. So you can create a JSON file with a bunch of key bindings by just having an array of these key binding options objects and then adding them to the registry when you start up. So the first one is an array of basically keys that, key sequences or key chords, if you will, that you want to be triggered when the user presses those keys. So an example would be Excel C. And Excel, again, that's Control on Windows and Linux or Command on Mac. You have like Shift F11, for example, or you can have an array that's separated by commas. So you could have DD if you wanted to use like a Vim key bindings where you're going to delete something like that. And it tells you here in the notes, the modifiers are Excel, Alt, Command, Control, and Shift. Excel is translated Command on Mac, Control on other platforms. And if you use Command directly, it's ignored on non-Mac platforms. What that means is that Control and Command are different things on Mac. Command is not supported on Windows or on Linux, but Control is. So there you go. So you can pass it your array of keys. If you want to override what that key binding is for a particular platform, you can specify different ones for the particular platform. So you can have, for a particular key binding, you can have a dedicated shortcut for Windows, a dedicated one for Mac, or a dedicated one for Linux. So if something doesn't make sense on one platform, you can override it or have different ones for each particular platform if you want. The second thing that you must provide is a selector. So this is a CSS selector for key binding. The key binding will only be invoked when the selector matches a node on the propagation path of the key down event. This allows the key binding to be restricted to user-defined context, and it must not contain commas. So you can't have multiple selectors in a single string. So what this means is that when the DOM detects a key press, it's associated with whatever node has focus on the current web page at the time. If nothing has focus, it's associated with the document, I believe, or the document body. But let's say there's something in the DOM has focus. The key down event is triggered by that node that has focus, and that event bubbles up the DOM path to all of the parent nodes until it gets to the body of until it gets to the document. At which point we're going to trap it and detect that key down event. The key down event carries along with it the target node that actually triggered the event, so the node that had focus when the key was pressed. What the selectors are used for and what the command registry does is that it starts at that particular node in the hierarchy that basically triggered the event, and it goes through all of the selectors that are registered, and it looks to see if any of the registered key bindings has a selector which matches that particular node in the DOM. If it does have a match, that's the key binding that gets executed for that particular key event. If it doesn't find a match, it steps up to the parent node, so it steps up to the next path on the bubble hierarchy. And it goes through the same process again. It looks through all of the key bindings that are registered, and it sees if any of those key bindings have a selector that matches that parent node. If it does, that's the key binding that gets executed, and so on and so forth until it finds its way all the way at the top of the document and either finds a match or it doesn't find a match. If it doesn't find a match, nothing gets executed, and you don't get any warning or anything like that because the user might be pressing keys that aren't associated with any key bindings, and you don't want warnings in that case. So what this allows us to do is scope key bindings to particular user-defined context. Like you may want the key binding double D to only be active when you're inside a notebook that has a CSS class name on it that says it's in Vim mode, right? And so you can do that with a CSS selector. So you just have a CSS selector that scopes down to a notebook cell with a class name that includes Vim mode, for example. And that's the only time the double D keyboard shortcut will be available and active. Similarly, you can have, the sky's really the limit there. And the reason we chose CSS selectors is because it's a well understood concept. They're stored in the form of strings, so they're compatible with JSON, and it allows you a lot of flexibility and allows the user a lot of flexibility to customize when particular keyboard bindings, keyboard shortcuts are active and when they're deactive and what they apply to, what they don't apply to. And most importantly, it allows you to reuse keyboard bindings. So you can have, in one context, Control-C means something when something is in focus, but in another context, Control-C means something entirely different. And there's no confusion and there's no competition between those two key bindings on which one's going to win, because only one is active in that particular CSS context. All right, so good. Moving on. The last required argument is the name of the command to execute when that key binding is triggered, or the ID of the command to execute, I should say. Optionally, you can pass in arguments for that command. In this case, I don't think we need UI args here because the key binding has no UI representation. Maybe you want to have execute args and is enabled args. I don't know if we want to take it that far, though. I think it's simple to just say, here's the arguments for the key binding. And then we already went over the win keys and the MAC keys. So these are the arguments that are going to be passed to that command execute function and the is enabled function for the registered command at the point the key binding is triggered. This key binding interface is the key binding. It's an immutable object created by the registry. So there's a method up top in the command registry called key bindings, which gives you an array of these things, and this lets you interrogate what key bindings are registered, currently, as well as the arguments for the key binding changed and some other stuff that isn't really important, but maybe you want to use it at some point. So there's a method, a public function here to parse a keystroke into keystroke parts, another function to normalize it, and another one to format it for display. So you may want to use these, you may not. They're more utility functions for Phosphor's use case that I thought might be useful to make public, so we made them public. And then there's this public method to process a key down event. So the command registry doesn't listen to key events for you because you might have multiple command registries in an application. You might have a command registry that's only associated with some subpanel in your total UI, and then you might have a global one. In JupyterLab, we just have a global one, but that's not necessarily the case for everything. And so the command registry itself doesn't listen to key events in the DOM. It's the responsibility for you, the author of the application, to inform the command registry that it should process a key down event. And you do that by calling process key down event with the keyboard event that occurred. In JupyterLab, we listen to the top level document, I believe, and then whenever a key down event occurs, we call process key down event on the application command registry.
And
you can usually add more than one and call it at different points in time.
Importantly, in JupyterLab, we listen to the top level thing in capture mode, in the capture phase. So we're getting every key down event, no matter where it's triggered in the app.
Yes, before anybody else gets a chance to process the key down event. So that means that this process key down event needs to be fairly efficient, which I believe it is. I think we're capturing everything and it still doesn't slow down your typing. So this is actually a method that actually executes pretty quickly. So basically it goes and it translates that key down event into a keystroke that involves using the global keyboard layout and some other things to handle the modifiers. And you can go through this implementation. It handles, makes sure that we're handling the timeouts correctly. So, one of the notes up higher in this module says that there could be ambiguous key bindings. Let's say you have a key binding that's Control-C, Control-K, and then another one that's just Control-C. Well, those are ambiguous. Which one do you mean? Like, I can't know that you don't mean the second Control-C until after a timeout has elapsed because you might be getting Control-K after that. So all of this logic in this method handles that timeout and replaying key down events if the timeout expires without you pressing the second part of the chord or the third part of the chord or whatever. It goes through all of the matching and all sorts of stuff. It's pretty involved logic, so I don't think I need to explain all of it. But that's
or maybe that's exactly why you should explain all of it. I will mention the normalized key bindings. I looked at it. It does actually ignore the command, just to wrap up some questions from before.
Okay, cool.
So that means if you do Command C as a keyboard shortcut on a non-Mac, that becomes C, I think, if I understand the code correctly. Which seems kind of dangerous, actually. Oh, okay. So sorry, I didn't realize we were going to keep going.
Yeah. Okay, so the first thing, it converts it into a keystroke. If the keystroke's not valid for the keyboard layout, obviously replay any suppressed events and clear the pending state. So suppressed events would be if it detects that a chord is being typed. So you've got, Control C, and there's something that comes after that, like Control K or something like that. What's going to happen is it starts a timer. So nothing happens. The event is suppressed so that it doesn't continue bubbling up the DOM, or some other part of the application can handle it. It swallows the event and it starts a timer. If the next keystroke fails to match anything, or fails to convert or anything like that, or the timer expires, that means that the chord, the timeout on the chord was not matched, and so the application should have an opportunity to handle that key down event. That's what this replay key down events does. So it actually, the user pressed something, we thought it might be a chord, it turned out not to be a chord, so now the application needs to get it. So we replay those key down events. And the first thing we check to see, we're going to get that key down event because we're going to dispatch it, but if we're in the middle of replaying those key down events, we ignore them and we don't process them. So that's what this clear replay key down events is, and then we clear the pending state. This, obviously clears out all the timers, clears all the events that we saved to replay, etc. Otherwise, the keystroke has converted to a valid thing, so we add it to the end of the current keystrokes array. So we're actually the current key sequence. So we basically, if there's a bunch of chords, we start adding these keystrokes to an array so we can process them. Then we go through this match key binding method. So this is a function that takes whatever key bindings are registered, the current keystrokes that have been pressed, and the event, and it returns whether we have an exact and whether we have a partial match. If we don't have an exact and we don't have a partial match, so an exact match would be, hey, here's the exact key binding that was matched, and there might be a partial because it might be a chord. So if you don't have either of those, nothing was matched. In that case, we replay any pending events and we clear the state again because nothing matched. Otherwise, we have had a match. Either we've gotten an exact match, or we've gotten a partial match, or maybe we've gotten both. In that case, we swallow the event because we're going to do something with it now or maybe later. And so the application should not get the rest of this event. So we go ahead and we swallow the event. If we have an exact match, but we don't have a partial match, i.e. like the user pressed Control C and there was no other Control C, Control K thing registered, you're going to have an exact match and you're not going to have a partial match. In that case, we can execute the key binding and we can clear any pending state that we had saved. Otherwise, that means we have either a partial match or an exact and a partial match. If we have an exact match, we store it, and then we add the key down events because we do have a partial match. So now we need to start a timer and wait to see if the user completes that chord. If they don't complete that chord, then we do have an exact key match. So that's the one that will be executed. So it's kind of a bit convoluted logic because you have a timer and you basically re-enter this method a couple times. But does that make sense? How the logic here works? So you kind of got two things. The user can press a key, it either matches nothing and nothing happens. They press a key, it only matches an exact key binding and not a partial key binding, so it's triggered immediately. It could only match a partial key binding, in which case we start a timer and see if they finish the partial binding later. If they don't, then we replay that event so the application can handle it. If we get an exact match and we get a partial match, we store the partial and we store the exact, and we start a timer. If the timer expires without the partial match being completed, then the exact match is executed. Otherwise, the partial match will be completed, and that's the one that we execute because it's more specific.
Wait, where do we store the partial match? I see where we store the exact match.
You don't have to match the partial because it's the keystroke is added right here, and so the next time you come through and hit the next key, that partial is going to become the exact match.
Yeah. Or at some future time, right?
At some future time.
Yeah.
And then the rest of the methods are just dealing with starting and clearing the timers and replaying the events and executing the key bindings.